In this lesson, we're going to be looking at infinite geometric series as it pertains to repeating decimals. And so what we're going to do here is we're going to write the repeating decimal as an infinite geometric series. And any repeating decimal can be written this way. And so we're going to write it as an infinite geometric series, and then we're going to find the sum of that infinite geometric series. Okay, using the formula for a sum of an infinite geometric series, which remember that formula is this guy. It's the S equals a sub 1 over 1 minus r. Okay, that's the formula we're going to be using. And really the goal here is to take this repeating decimal from a decimal to a fraction. Because when we think about repeating decimals are rational numbers, which means we have to be able to write them as fractions, because that's what a rational number is. So this is really the process for why we can rewrite them as fractions. Okay, so if we look at this first one, what this means, and we should already know this, but this means that we have a 0.3333, and that 3 just keeps going forever. Okay, so that's what that means. And here's how we're going to write this as an infinite geometric series. Basically, we're going to write this as the sum of a bunch of different values. So if I want a string of 3's, I would need a 0.3 plus a 0.03. And when I added those together, that would give me 0.33 plus another 0.003. That would give me 0.333. And so if we continue that pattern and we keep doing that forever, what's going to happen is we're going to keep tacking on 3 after 3 after 3 until we have 3 repeating forever. Okay, so this is written now as a series, and it's an infinite geometric series because 1, it never ends, it keeps going forever, and 2, it's geometric because the pattern is to get from one term to the next. You might be able to see it better in terms of division, but we are dividing by 10 each time. So if we're dividing by 10 each time, we know that that's geometric. It means that what we're really doing is multiplying by 1/2, or sorry, by 1/10. So really what we're doing here in terms of the R value here is 1/10. Okay, if I'm dividing by 10 each time, it means I'm multiplying by 1/10. And so really, we look at that R value, falls between -1 and +1, so I can find the sum. I just need a sub 1. In this case, a sub 1 is the first term, it's right here. But that's a 0.3, we want it as a fraction instead. That's 3/10. And so now we use our formula. The sum equals a sub 1, which is the 3/10, over 1 minus r, which is the 1/10. And I just simplify, that's 3/10 over, it's going to give me a 9/10. And now dividing by a fraction is the same as multiplying by the reciprocal, so I'm going to multiply by 10 over 9. And now I can cross reduce the 10 and the 10 reduced to a 1 and a 1, the 3 and the 9 reduced to a 1 and a 3, and now I multiply straight across, and I end up with a 1/3. And really that's not surprising to us. This is one of the few repeating decimals that we know. We know that 0.3 repeating forever is 1/3, but here's why 0.3 repeating forever is 1/3. Okay? If I look at the next one, I can kind of do the same thing here. Again, if I think of this as an infinite geometric series, that would be like 0.1 plus a 0.01 plus another 0.001. And so what's happening here is I'm tacking on 1 after 1 after 1 until I have a string of 1s that continues forever. Okay? So now I identified the R value in this one. Again, I'm dividing by 10, so I'm multiplying by 1/10. That's my R value. And then my a sub 1 is the first term, and when I look at this first term, it's 0.1, which is a fraction, would also be 1/10. And so the R value falls in the acceptable range, so I'm going to find the sum. So S equals 1/10 over 1 minus 1/10. So that's 1/10 over 9/10. And now dividing by a fraction is the same as multiplying by the reciprocal. And I do some reducing. The 10's cancel to a 1 and a 1. That gives me a 1/9. We can easily check that on the calculator. Do 1 divided by 9, and you'll find out that it gives you a 0.1 repeating forever. Okay? If I look at the next one's a little bit trickier to write in terms of a geometric sequence, or series rather. But really it's this. I know I have a 0.36, and then what I have to add to that, in order to put the 36 on the kind of tacking onto the end of this thing, what I need is a 0.0036. And so really those two zeros kind of hold the place of the first two numbers, the 3 and the 6, and then we tack the next 3 and the 6 on behind that. The next one would be a plus 0.000036, okay? And so I would keep getting 36, 36, 36, 36, okay? And so now the pattern, when I'm looking at this thing, to get from one term to the next, I'm dividing by 100, which means my R value this time, sorry, I just made a mess by dragging my hand across the screen, but my R value this time, since I'm dividing by 100, means I'm multiplying by 1 over 100, so that's my R value. And then my a sub 1 is the first term, which is the 0.36, which as a fraction would be 36 over 100. Okay? And so now I'm going to find the sum, so the sum equals 36 over 100 divided by 1 minus r, which is 1 over 100. So that's 36 over 100 divided by, that's going to give me 99 over 100. And now dividing by a fraction is the same as multiplying by the reciprocal, so 36 over 100 times, that's going to be 100 over 99. And now I can start reducing this thing. So I cross-reduce, the 100s cancel out to a 1 and a 1. The 36 and the 99 can be reduced by a factor of 9, so that's a 4 and an 11. And now I multiply straight across and I get 4 over 11. Once again, I can check that very easily on the calculator. I do 4 divided by 11. Alright. So now from here, before we move on to the next one, there's a great shortcut that we can use for these. And really, when you look at it, you'll notice here, the shortcut is, if you don't see it, if you do see it, that's great. But we can go right to putting this thing over a set of 9. So like when I have one value repeated, like up here, I have one value being repeated, and that one value is a 3, so I put that 3 over a single 9, and that reduces to the 1/3. Okay? On the next one, I have a single thing being repeated, and it's a 1, so I put that 1 over a single 9, and I can't reduce that one, and it's 1/9, and that's the answer I got. When I look at the next one, I have two things being repeated this time, so I put the two things that I have being repeated, the 3 and the 6, and instead of being over 1/9, since it was two things being repeated, I put it over 2 9s. And of course that reduces to a 4 over 11. Okay? And really the reason for that shortcut is because mathematically we always have an R value that's 1 over a power of 10. And what happens is when I write the initial amount as a fraction, it's always going to be something over that same power of 10, and so when they cancel, it leaves me with these 99s. But really, it's something we noticed through a pattern. Someone did this geometric sequence enough times that they realized I can just slap this thing over that many 9s. So if I use that shortcut for the next one, here I have two things being repeated, the 6 and the 8, so I put the 6 8 over 2 9s. Okay, it was a pair of numbers, so I put it over a pair of 9s, and that can't even be reduced. That's it, and you can easily check it, plug it into your calculator. And then the last one, again, I could use the geometric series, but I can just take the three things being repeated, the 1 1 2, since it's three things being repeated, I put it over 3 9s. And that's it, and that one doesn't reduce either. Okay, and I can easily check that on the calculator. Alright, now this is a great shortcut to have, and it's wonderful, but like most shortcuts, it doesn't work all the time. Alright, so we have this great shortcut, it only works when the entire decimal is being repeated. So notice that bar is over the entire decimal for each of these. The issue we run into is when we get an example like this. Okay, this example, the bar is only over the 7, so only the 7 is being repeated, which means this decimal looks like this. It's 0.37777, and just the 7 keeps repeating forever. Okay, so we had that 3 once, and then the 7s repeat forever. So with this one, we can't just slap this thing over a set of 9s because the whole decimal is not being repeated. So I'm going to break it down to a geometric series. So I've got 0.3 plus, it's going to be a 0.07 plus a 0.007 plus a 0.0007, and of course that pattern continues forever. But now the issue here is what I have written is not a geometric series, okay? And the reason it's not a geometric series is because that stinking 0.3 out front, I can't do anything with that thing there. So this is not a geometric series unless I get rid of that 0.3, or in my case, what I'm going to do is I'm just going to kind of ignore it. All right, I'm going to do this separately, so I'm just going to kind of cut this guy off from the rest of the problem. All right, and I'm just going to do each of these individually. So when I look at like the 0.3, I can convert that to a fraction. It's 3 over 10. And I'm going to take this whole thing right here, and I'm going to convert it to a fraction. Okay? And so really, I'm going to do that because this is a geometric series. I just had to identify the R value and the a sub 1. Well, the R value, the decimal is moving one spot each time I'm dividing by 10, the r value is 1/10. And then a sub 1 is my first term, that's the 0.07, which is 7 over 100. So now the r value falls in the acceptable range, I just find the sum. So I'm going to find the sum of this piece. So that's going to be a sub 1, which is 7 over 100, divided by 1 minus r, which is the 1/10. Now I just have to simplify this thing the same way I did before. It's going to be a 9/10. Dividing by a fraction is the same as multiplying by the reciprocal. And now I can reduce this thing a little bit, the 100 and the 10 reduced to a 1 and a 10. And I multiply straight across. That's going to give me a 7 over 90. So what happens here is this geometric sequence series part ends up giving me a 7 over 90 when it's all said and done. And if I were to punch in 7 over 90 into my calculator, it would give me 0.07777 with that 7 repeating forever. So the only thing that's missing is that 0.3. So the 0.3 is actually this 3/10. All I need to do is add these things back together the way they were to start. Okay? So I'm just going to go ahead and add these two things back together, which means I need to get common denominators. So I multiply this one by 9 over 9. So I end up with a 27 over 90 plus a 7 over 90, which is 34 over 90, which reduces to a 17 over 45. And then once again, I can easily just plug that right back into my calculator, and it'll give me 0.3777777. And that'll keep repeating forever, okay? The calculator might round it up at the end, but that's it, all right? Same thing with the next one. If I break it down this way, so I do a, that's going to be a 0.5 plus a 0.012 plus a 0.00012 plus a 0.0000012. And of course, that pattern continues forever. And so again, one of these things not like the other. One of these things just doesn't belong. It's that 0.5. So I kind of cut that thing off from the rest of the problem. I say, okay, 0.5 as a fraction is a 1/2. I can deal with that guy separately. And now I'm going to deal with the rest of this thing all on its own as well. So I identify the r value. In this case, I'm dividing by 100 each time, which means the r value is 1 over 100. A sub 1 is the first term, which is the 0.012, which as a fraction would be 12 over 1,000. And now from here, what I can do is I can just plug this into my sum formula. So I do S equals a sub 1, which is the 12 over 1,000, divided by 1 minus 1 over 100. And now I simplify. That's going to be 12 over 1,000 over 99 1/100ths. Now dividing by a fraction is the same as multiplying by the reciprocal. And now I just start reducing this thing. So the 100 and the 1,000 reduce to a 1 and a 10. The 12 and the 99 I can reduce by a factor of 3. That's a 4 and a 33. And then even over here, the 4 and the 10 can reduce to a 2 and a 5. And now when I multiply straight across, that gives me a 2 over, that's going to be 165. All right? So then what I have here, if I jump back over, I have this first piece ended up becoming just a 1/2. The second piece ended up becoming a 2 over 165. If I want back to the original, I just need to add those things back together. So I put a plus sign in between, and now I just have to get common denominators. This one I've got to multiply by 2 over 2. This one I have to multiply by 165 over 165. So I end up with 165 over 330 plus 4 over 330. And when I add them up, it gives me a 169 over 330. Okay? And so now what's neat about this, there is a shortcut we can do. It's not the same shortcut we did before. We're going to utilize that shortcut to do something just a little bit differently. So with this last one, I'm going to show you this shortcut that we can possibly use. And basically what's going to happen here is we're going to break this down into the repeating part and the non-repeating part. So here's the non-repeating part. Plus the repeating part would then be 0.0240. And that's going to repeat forever. And instead of actually writing this out as a geometric series, we're just going to leave it like this. And I'm still going to do this kind of in two chunks. The first chunk, I'm going to do the same way I did before. That's 4 over 10, which is really a 2/5. Okay. The second chunk, I'm going to kind of think of it this way. If we think about this guy, think about how decimals work. If I had something like 0.024, that would be the same thing as 0.240 divided by 10. Okay, and we can all agree that, yeah, that's the same thing. If I divide by 10, it moves the decimal one spot. So that stands to reason then that 0.0240, same thing with a bar over it, would be the same thing as 0.240 with a bar over it divided by 10. Okay, just like it was in the previous example. All right, and that seems kind of insignificant. And oh, okay, yeah, if I divide by 10, it moves the decimal place one spot. But if we write this fraction, this guy right here, as that fraction, as 0.240 with a bar over it divided by 10, well, now when I look at this first piece right here, this guy I can use the shortcut from the previous section on, okay? Because the whole decimal is now repeating, I can write that as 240 over 999. Okay, I can use that shortcut that we learned previously, but I had to take that extra step of rewriting it first. So then what I really have here is I have 240 over 999 divided by 10. All right, and it's a little bit of a pain to have to deal with those fractions, but remember, dividing by 10 is the same as multiplying by 1/10. So what I really end up with is 240 over 9,990. Okay, and then I can reduce this thing so I can simplify it a little bit. So I've got my 2/5 plus, when I reduce this thing, I can divide each of these by 10 for sure, and then I could divide each of them by 3 as well. So really when I reduce this thing, I can reduce it all the way down to 8 over 333. Okay, and now from here I just have to get common denominators. So what I'm going to have to do is I'm going to have to multiply the first one by the 333 over 333. I'm going to have to multiply the second one by 5 over 5. And so what I'm going to end up with here is I'm going to end up with 666 over, that's going to be 1,665 plus, this one's going to give me a 40 over 1,665. And I add them up and I get 706 over 1,665. And so that's the shortcut that we can use with these. Split it into the non-repeating and the repeating part. Then the repeating part, rewrite it using division of 10 or 100, whatever it happens to be. Rewrite it so that part of that has the entire decimal repeating, and then you can use your shortcut from there and just deal with the fractions. Okay?